Hi guys, I hope you're good since last video. So in this video we are going to focus on Rust casting, so the conversions. The introduction is not going to be long. We're going to be jumping straight into the explanation part. Now you are used to it. On the second part we will be going into the terminal and doing some hands-on. Please like and subscribe. Even if you're coming for a few seconds, like and subscribe. And let's get started. Casting. So casting, conversion in Rust. You're going to see different types of castings. Limitation, how to do it. So integer conversions. You can use as keyword to convert between integer types, such as converting usize to a u64, or between i32 and u16. Here, 42 is a usize, and the u64 here, we're going to be converting index usize into a u64 using the as keyword. So this conversion is valid because Rust allows explicit casting between integer types. However, be careful when converting between types with different sizes, as this can lead to truncations or loss of data. Okay, so floating point conversions, that's another type of conversion. You can convert between floating point types like f32 to f64 using as keyword as well. So here we check p number, it's an f32, and after we're going to use the as keyword p as f64 to convert it as an f64. Integer to floating point and vice versa. So you can use as the keyword to convert between integers and the floating point types. So this is also possible. Here we have a number 42, and here we convert it as an f64. So e32 to f64, we have an f64 here, and we're doing the other way around. The float has an e and i632. Alright, so pointer conversion. The as keyword can also convert between references and the row pointers. So here we have an example with the s is a string from hello, and we use the %s, which will be pointing to it. And you can see here we say let row pointer, we put the star const string equal, and after we are here doing the conversion, %s has const. You see %s here, as we put the star const also here. So this conversion is common when dealing with low-level pointers manipulation, although such operations are generally considered unsafe. And casting between characters and u32, so you can use as to convert between characters on its Unicode Scala value u32. So you can do that also to get the here a becomes 64. So the limitations of the as keyword, so you can use as, but there are some limitations. While as is versatile for simple primitive type conversions, there are many cases where as cannot be used. So some of the key limitations include converting between complex types. So you cannot use as keyword to convert between arbitrary complex types, like converting a string to a vector u8, or converting between custom struct types. So these require more explicit transformation via methods like into method or from method for own types, or trait implementations. So you can also use implementations for that. For example, this won't work. Example here with a let s string from hello. The vector you want to use a as keyword, s as vect, having u8. If you want it to work, instead, you need to use a method that already exists, est, into bytes, and here it's going to convert the string into a vector u8. So it depends also on how long is the string to be able to fit in that type of vector. Potential data loss. So casting between numeric types of different sizes, like casting a large U64 to a smaller U32, can result in truncation. Rust allows this with as, but you need to be careful of the possibility of data loss. So here we're using a big number, U64, like we just put a big number, and the small number is a U32. So the big number, if you convert it as 32, it's going to be possible, but the value is going to be truncated. We're going to lose some numbers at the end. Casting between unrelated types. So you cannot use the as keyword to cast between unrelated types, like string and the i32, completely different. Rust type system ensures safety, so arbitrary conversions that could result in undefined behavior are not allowed. Rust requires explicit conversion function like toString, parse, when transforming between types that do not have a direct, well-defined conversion. This is probably the last page of the explanation part, alternatives to as for conversion, so you can use into or from threat. So for more complex types, Rust uses the into and the from threats for safe conversions. You might see code like this. So S, same example with hello as a string. We have the bytes vector u8 and we use s.into, where the string here is converted into a vect u8. So the into threat allows for safe and flexible conversions, and it's often preferred when working with non-primitive types. So similarly, you can use from to define conversion between types. We have also try into for variable conversions. So when a conversion might fail, Rust provides the try into threat, which returns a result. So here we use an example where we have an i32, 1000, a number, and we have a small number, it's a result type of u38, or the OK part, and the num try into. It may fail if the num is out of range, and after we use a match statement to handle that. So it's always better to handle it this way, with a match statement, to have full control and also to be coding safe. Let's have a break. Please like and subscribe, and let's go to the coding part. Okay, let's go in the terminal. That's what we've done before. We're going to create a file as usual, and we're going to call it nano. We're going to call it casting manga kisa as usual, services.rs. So here we will have different services using numbers, and we're going to be playing with casting and going incrementally in more complex examples. I'll try to just stick to 3 different examples so that the video is not too long. So in the example 1, we're going to use just a public function, normal casting. So that's what we're going to do here. This just to illustrate what we've seen in the explanation part. We create here a variable total manga read of type u32. I just put the types like that, even if Rust can infer the types, but I want to be able to choose which types in order to play with those conversions. And after here we have a cost per manga. It's an F64, 5.5. It's all in yen, Japanese yen. So let's cast from U32 to F64 to ensure proper multiplications. So let total costs, which is of type F64. So the total manga read is a new 32, so we need to use the as keyword, transform it into an F64 so that we can use the multiplication and multiply it by cost per manga, which is already an F64. So those operations need to be done using the same type. Here we have casted the U32 type to an F64, and now we are going to print it. The total cost for reading mangas is, here we're going to use the, I don't think we need formatting, we just put GPY. Let me just put this. This is for the digits after the 0. Total cost, we just put a little comment here. So here we got colon.2, okay, for how many digits we want after the comma, right? Let's close those comments. So we have a function here, normal casting. I'm just going to copy it, and here is casting manga kisa services. Might copy this, it's longer. Let's go to the main.rs as usual, and here we are going to call this module. Perfect. And we're going to use the module to call the public function and get the result in our terminal, which is called normal casting. Now let's use cargo and run it. Cargo run. The total cost for reading mangas is 231 yen. This is very cheap. Just to show you here, I'm going to put 12 digits, for example, and you're going to get, after the 0, 12 digits, as you can see. Okay, because we haven't used that before. So now we're done with the first example. It was quick, it's a simple. This is just going along with the explanation part. And now we are going to start with the example 2, which is going to be more complex, as I'm going to try to use a struct. Let's go with this, example 2. So we're going to be implementing, putting this decorator, derive, debug, to be able to print. We're going to use generics at the same time. So we have a struct manga rating of type T, because we will have one field with this type T. It will be more flexible, the ratings. And we're going to implement. So we implement the type T, manga rating, type T, and now in this implementation we need to precise, because we want T also to implement into F64. So we'll be able to convert, plus copy, so that we don't move the ownership. We play with the copy of it for any operation that we're going to do. So here we create the function that we're going to implement. This is as usual. We're going to call it rating as float. We use %self referring to manga kisa struct. It's going to return an F64. And here we're going to be converting generic rating to F64. because the type is T, so we need to convert it to an F64 in order to be able to make any operation on it, any calculation. So self.rating.into, so we access to the Mangakisa rating field, which is a type T, and after we use the into. So because we have the type T implementing into, as we put where T implements into F64. So here, just using self.rating.into. So the into method at the end is going to be performing that conversion to an F64. Okay, so this is for the struct and his implementation. Let's create now the public function. So we're going to call it public function generics in structs. Let's make it simple. And we're going to be instantiating that rating by getting that field. Mangakisa rating is a U32. So it's of type Mangakisa rating U32. And we're going to be instantiating Mangakisa here rating. And we put colon and we say 85. So it's a U32 and it's 85. And we're going to be printing a little message. Don't need to overcomplicate what is inside the function. Here I just want to use a struct with generics. Original rating. We have implemented the deriv debug with the decorator on the struct. So we will be able to print this T type, which is not implementing display. Okay, so the first print is the original rating, and the second one is the rating has a float. So here we're going to be calling the method that we have implemented to manga rating, which is called rating has float. That's the one here. Okay, this one. So that's the one that we're calling down there. It's going to be transforming it into F64. So I don't know if I need here to add also display for that. So I'm not sure if I need it in display. It wouldn't be after the comma, it will be before the comma with a plus. So it will be just, let me just push this like that. So you can also do it like that. But I'm not sure. I'll just leave it like that for the moment. If it doesn't work, the compiler is going to tell me to come back. Because F64, it should be able to print F64 after conversion, right? While the T type, it can't be printed. So we need to use this implementation. So here I'm just going to comment out what we've done before. And I'm going to call that function that you have created. So not this. Get rid of that. So that's the module name. This we can put it like that, and the function is, what was it? Generics in structs, something like that. Okay. So let me comment out what we've done before to just have a clean print of just one example. And here we go. Original rating, manga rating 85, instantiation. Well, here the rating has float 85. So what I might do is maybe take one of my functions that we've been using in those tutorials to print the types. I'm just going to fast forward this and print the type. Let's change the function a bit. I'll call that function cargo run so that we can see how the types are different. So the first one is a resting, is a casting manga kisa service manga rating U32, and the second one is an F64. Okay, so we can see here the different types. Okay, so we're good for the example 2. Those were quick, so that we can stay on the next example. So this is the function that I've used, that we've been using in some of the tutorials. I'm going now to comment out this function, all the example, and let's jump into the example number 3. Okay, so here we're going to make it a bit more spicy. We're going to have a struct, we're going to have implementation, but we're going to add some extra implementations, some extra types also of custom types. Here we will be doing our complex example with enum. So that's what we're going to be introducing here. So that's good to see it this way also. You can go back to some videos and understand the use of those types like enums. So I found it interesting to use generics, to use implementations and structs. Doesn't mean that I have full control of it and I've mastered it, but this is how you play with it in order to learn. So implementation that will use casting to handle scenarios. Okay, so we'll have different scenarios here. The enum will have different types. So we're going to need here to import. As we've seen in the explanation part, when you have custom types, you might need to use from or into and some other methods. So here we're going to be importing standard library convert from. We're going to be also importing standard library from the formatting the display, and from the OPS add. Add will be to do those additions. We're going to use our decorator so that we don't need to implement display for this one. Derive, debug, and here the enum is called manga kisa type. At the beginning I've called it manga kisa type, but I've added enum so that you're not confused while we'll be using it in the main function, because the names are a bit similar, so you know what is coming from an enum and what is coming from a struct. So here we will have manga kisa type enum with 3 different types: basic, 32. We'll have also deluxe, F64, and the VIP, which is a string. So here I'm going to be putting allow dead code, because I might not use all the different fields. Otherwise this example is going to be too long if I want to show you for every single field. So we'll be focusing on some of those fields. So enum with different types of services. So those are different types of services. So we want to have a field of the struct being able to take any of those types. So to have multiple types, you use an enum, you create all those different types, and after we're going to be defining in the struct one field or several fields using that enum as a type, so that it can have a flexible typing. So here in the struct is called manga kisa manga service, I'm gonna add a struct after. Using generic type T, the cost is of generic type T, and the service type is of type the enum, Mangakisa type enum. So it will be able to be a basic, deluxe, or VIP. So here I'm just gonna add struct, so you're not confused after when you see when you're using it. So here we're doing an implementation on Mangakisa service of T. So implementation T is because it's a generic type. We want the T type to be implementing add the output back to a T type, plus also implementing from a U32, implementing copy to play with it, and here we're going to be putting the implementation of display. So you test if you need display or not, but here I put display. I don't want to be making the video long, playing with the compiler, coming back to correct those errors. So let's make it safe directly from the beginning. So the T type has to implement add to add up. I'm just going to be commenting on those implementation. So for plus, minus, here is for plus operations. It would be div if it was a division, for example. So from implementation from U32 is to cast the type T, okay, to cast the type to T types. So the U32 will be casted copy to not move the ownership, otherwise we'll get some troubles. So we use the copy thread in order to be able to make those calculations. Display for the printing, okay, using display, using just the curly braces without any question mark. And here we're going to put our logic in this scope. So let's make our function implementation. So the function here is called upgrade service, which is going to take a reference of the struct and an extra field, which is the extra cost to upgrade. Is of type T, and it's going to be returning a type T also. That's what's going on in between. What's going to happen? As T implements add, so we have implementing add in the where statement. We can use plus operations, okay? So let's make this calculation. Self.cost, so the struct Mangakisa service struct, the cost field is of type T. Let me check. I'm just going to close this. And we're going to be just multiplying it by the extra cost. Extra cost. Here I put service struct. Okay, we implement it to the struct. We use the same name. I did the struct at the end, as I told you, just to avoid any confusion of what is struct implementation, what is, because the names are a bit similar. Okay, we have here all the imports. We have an enum, We have created a struct. We have created an implementation to that struct using those generic types. Now, can maybe create another implementation. So let's implement. I'm going to create another one. Conversion for the enum type. Let's make it a bit spicy. So we're going to be using the from that you have imported. Implement from manga kisa type enum, which is a custom type. That's why we're using from for F64. Okay, that's how you're going to be saying it. And after inside we create a function from manga type, which is of type manga kisa type enum. That's the parameter of the function and the type of it, and we want it to return an F64. So here we will be able to convert those fields. Okay. So here we're implementing from thread to convert manga kisa type enum, okay, to an F64. Okay, that's what we're doing here, and we're passing in the fields in our implementation. So from here helps to be able to use it wherever we want. So when you're doing the conversion like that, this is more portable code. You can reuse it somewhere else. Okay? Instead of creating special functions every time, you need to use it. So whenever we want to convert manga kisa type enum to an F64, instead of having specific separate functions for each cases. Okay, you just do one implementation. In the implementation you handle all the different cases. How? Guess before I write it. I already write it. So let's use match, and you use your match statement to match all the different cases that can happen to that field, to the fields of the enum. So let's use match pattern for possible occurrences. And after you go match, and you're gonna match manga kisa type. Manga kisa type, okay, you're gonna be able to make it here. And after here we put the scope, and we're gonna be defining all the different cases. So manga kisa type, manga kisa type enum, so here let's call the field basic. We're going to put cost as a placeholder. So if it matches the basic field of manga kisa type enum, the basic field we already know that it's not an F64, we're going to use as F64 to cast it. Okay, and for the other fields it's going to be a bit different. So here maybe cost, this is deluxe. So here deluxe is already an F64, so we just want it returned. This is going to be the right type. The VIP, this one we're not going to use it. I just put a random number, which is going to be default number. So So if we wanted to use it, we would get the default number. But 1000 yen is not very expensive. I'm going to make it Ichiman, which is 10,000 yen. Here we just use a default F64 value for VIP, Ichiman yen. So 10,000 is Ichiman yen in Japanese. Okay, it's very important to know that. Okay, and after here, costs, just a placeholder, is already an F64. No need, so we don't need to convert it because it has the right type of the function returned type. So we said that the function had to return an F64 error. That's why we're trying to use this match pattern in order to do those conversion individually. Okay, and here cost, I mean the basic one, the basic field of Mangakisa type enum is an U32, so cost will be a U32. So we use as to convert it. So whatever you pass in this function, the manga type, it's going to detect if the type is a U32, an F64, or a string. So it's going to match the types. Could have added another match for any error, but we're going to just leave it like that. And now we can create a public function and play with it a bit. But the hardest part is already passed. It's just explaining and going through those different implementations. So the public function Mangakisa services, we're going to instantiate this deluxe service, manga services struct. Yes, that's how I called it, manga service struct. And after, inside of it, so you know what we are going to do. Cost, we have one field. So the deluxe 150, maybe just 7. I'm going to put it at this price, 7,500.5 yen. The service type is of type Mangakisa type enum, remember, and here we choose the field deluxe. And here the deluxe was an F64 already. I'm just going to put the same, 7,500.5. This is just defining, instantiating that deluxe service. Okay, and here we're going to create another function, upgraded cost. So we're playing only with the deluxe field of the enum. Deluxe service dot upgrade service, because we have implemented upgrade service to the to the struct. And here I'm just going to make the difference, 10,000 minus 7,500.5, it's 2,499.5 yen. Just want to make it 10,000 at the end, so Ichiman yen, because if we upgrade it has to be then at the price of a VIP, which is by default 10,000 yen. So after here we're just going to print upgrade cost upgraded cost. Okay, let's keep going. By now, converting cost. So converted cost is a variable of a type f64, and here we can use f64 from, because we have implemented into the Deluxe service, into the Manga Kisa, the Manga service struct. We have implemented the f64. Now we have used where here, implementation. So that's what is interesting here, is that we created the service type here. It's of type Manga Kisa enum. Manga Kisa enum, we created an implementation, and that implementation has for the T type, generic type, implemented the from, and the from was a converter to be able to convert it to an f64. So now we can use f64 from Deluxe service dot service type, and after we're just gonna print it. And what is interesting here is different ways of doing it. You can also use into method, but for the moment we're gonna go like that. We're not gonna overextend the example. So we can do this because we have implemented from to convert Manga Kisa type enum. Okay, just write it down as a comment, because my explanation, I don't know if it is confusing. So here it's written to an f64. We could use, I'm going to show you how we could have used it in another way. As I told you, we could have used the into method. So like that. So here we would have just gone like, let convert cost f64 equal to, and after we would have called Deluxe service under the service type field of the enum. Service type field of the struct, and here called into directly. And this would have converted it into an f64, because I put let converted underscore cost after I've defined after the colon f64. So the into would have checked that type and have casted that field to that type. Okay, so into threat is automatically implemented when from is implemented. So because we implemented from U32, here we got the into threat automatically available to us. We can use it. Let's take this, Manga Kisa services. That's the function name. We're going to go into the console, call the main.rs, update our new method, public method from the casting Manga Kisa services module. So let's call the function mangakisa services, and let's see what the compiler is gonna say. Okay, what did I do? Okay, enum mangakisa type enum. You see here there's an issue. Put a generic type for it. I'm not using any generic type in the fields of the mangakisa type enum, as I have defined those. So this is a confusion. We need just to get rid of this T, because this was for the struct only, not for the enum. We go in the right file here. Let's go down. Here you can see we have VIP is a string, deluxe is a F64, and basic is a U32. We would have put just a T here instead of U32 or something like that, but I don't have any field using generics. We can go run again. Okay, there is a colon missing. Let's find that colon. Not colon, semicolon. Where is it? Here, deluxe service. We have instantiated manga service struct. We have defined costs on service, but it is a let, so it's a variable defined. So we need to close it. Okay, and here we got what we want. Upgraded cost is at 10,000 yen, and the converted costs from the enum. So I could have printed also the types, but now you understand what I wanted to show you about casting. I'm going to make it short. Please like and subscribe. Hope that you like this video, and see you next time for another Have a Break, Have a Rest session.